All right, well, thank you. It's nice to be here. I'm going to talk mostly about energy efficiency measures at McCormick, since this is an energy conference. A little bit about renewable energy, and then I do have one or two slides on some other sustainability projects. Seems like anybody I work with on energy, they're kind of wear a lot of hats around sustainability. So I've got a couple interesting sustainability projects that I'll go over at the end. And also, if anybody has any questions throughout, just raise your hand. It's a lot more interesting if we actually get a little bit of a discussion going rather than me just talking at you for 15 slides. So McCormick put out its first CSR, Corporate Social Responsibility Report, a couple years ago, just showing that we have a commitment to sustainability, particularly being an agricultural company where the product we sell is you will actually eat that, so it's obviously important that it's clean. If you're going to be ingesting it, and it's important for us to have a clean supply chain for our customers. One thing I like about my job is I don't get a lot of work assigned to me. I have a very broad scope. Really, if you look at that triple bottom line, which is the intersection of people, planet, and profit, that white section in the middle, sustainability, that's my job. So I can play around with a lot of different types of initiatives, and as long as I'm in that white boundary and I keep producing good projects, everybody seems to be pretty happy. So it's fun to have that kind of flexibility to kind of dabble in a lot of different areas. We do have some sustainability goals that are corporate-wide. We have about 36 locations around the world, and so we have 5 metrics that we're measuring using 2014 as our baseline, and the goal is for 2019. So you can see we have 10% reductions in electricity, solid waste, and water. These are on a per unit basis. Greenhouse gases 5%, and then packaging 25% reduction. Just to make a distinction with the greenhouse gases, that's on-site greenhouse gases. So in almost every case, that's natural gas. We do have a couple places that burn oil. In China, we had a coal plant that just switched over to natural gas. That gave us a big reduction in greenhouse gases. But typically, for my role within North America, greenhouse gases means natural gas initiatives. So one of the things I just saw was like Staples or Office Depot, one of their CSR reports just came out, and one of the things that stuck with me was they said the boring stuff works. They had all these great results around energy efficiency, and it had to do with things like shutting things off when you don't use them and lighting upgrades. So the boring stuff really does work. It's kind of a little bit of a pet peeve of mine that when I hear politicians talk about the future of energy, they're all talking about these big, huge things like nuclear energy or renewable energy or offshore wind. And one thing that gets completely lost in the discussion is just energy efficiency. So really, if you started with that, that would go a long way towards looking at our challenges in the future for energy. So one of the, again, the boring stuff works. One of our biggest areas of success has been lighting upgrades. So in just about all our facilities, we've replaced older fixtures and lamps with new ones. And you can see the types of reductions we've achieved. 50% in our warehouse and production areas, office areas 30 to 60%. Exit signs, 95%, because those are old incandescent that we went with LEDs. Parking lots, 75%. Just using different fluorescent lamps to put out the same output for less wattage. So it's a lot of success. One thing we're just now getting into is the LEDs. And interesting scenario you see at the bottom there. 10 years ago, we had almost all 400-watt metal halide fixtures for all our high bay areas, whether it's production or warehouse. We replaced them all with T5 fluorescent, which cut the energy in half. And that's kind of what we have right now. Moving forward, we're just now getting into some LEDs. We've got a trial going on up in Harford County, Maryland, which is about midway between here and Philadelphia. And we got a 72-watt LED that's putting out an equivalent light to the T5s that were 230-watt or the 460-watt metal halide. So we expect to have that project finished by the end of the year. We got a nice rebate from the gas and electric company, paying almost half the cost of the project, and we'll have about a 2-year payback with that. And then we also use occupancy sensors, so we don't have lights on when an area is vacant. Another area for energy efficiency, waste heat recovery. You can recycle heat the same as you can recycle an aluminum can or a piece of paper. So we have one process where we're pasteurizing batches of extract. We heat it up to 200 or so degrees, and then we have to cool it back down to room temperature before we can package it. So when one batch leaves the pasteurizer, it preheats the next batch coming in. So we're effectively cooling what needs to be cooled with free energy from the incoming batch, and then it's also preheating the next batch going into the pasteurizer. So it's called a regenerative heat exchanger, and it's recycling that heat and saving about 80% of the energy that those two heating and cooling processes. Compressor waste heat recovery. This is something we're just getting into. We actually don't have any projects implemented yet, but if anybody's familiar with compressed air, it's a very expensive utility. It's notoriously wasteful and inefficient. So a typical air compressor will only take about 15 to 20% of the electricity put into it to actually provide any service for you, or move an air cylinder, provide any motion or utilization. So the other 80% of that electricity is all in the form of waste heat. So if you have a use for that heat, so like with the CHP, you got to have a sink. But if you have a use for that heat and can capture it, you can get a very high percentage of that waste heat. And then that whole process of your air compressor, instead of being 15 to 20% efficient, you can get up to 70, 80% for the, efficiency. So we're in the midst of that right now. We have several projects underway that we're scoping out. Hopefully we'll get implemented next year to take advantage of the waste heat. High efficiency motors. If you have some older motors in your plants that were standard efficiency and you haven't replaced them yet, the newer motors out there could be as much as 8% more efficient. If you look at a motor that runs around the clock, a 40 horsepower motor, for example, uses $2,500 a month worth of electricity. So that's $30,000 a year. If you can save 6 to 8% of that, you can save a couple $1,000. And that whole motor only costs about $2,000 for a 40 horsepower motor. So you can, on a highly utilized motor, you can almost justify replacing it before it even fails. If you're looking at new motors, you should definitely spend the additional few $100 to get the most efficient motor you can find. It used to be called NEMA Premium, which was beyond the standard efficiency. A few years back, NEMA Premium became the minimum standard, so all motors are now NEMA Premium. As soon as that NEMA Premium standard came out, the manufacturers started making what they call Super Premium, so they go beyond the NEMA Premium, and you can pick up a couple extra percent efficiency. Another note about motors is it's a fairly common practice for big motors to rebuild them if they fail. When you do that, they can lose a few percent efficiency, and it still costs money to rebuild that motor. It may cost half as much as a new motor. So we have stopped the practice of rebuilding old motors. If a motor fails, we're going to replace it with that NEMA Premium or Super Premium model and go for the efficiency. It'll more than make up for it over the life of that motor. Variable speed drives. I had heard a lot about variable speed drives. I didn't quite understand where the energy savings come from. But according to what's called the affinity laws, the energy that a motor consumes is proportional to the cube of its speed. So if you slow down a motor by just 10%, the energy consumed would be 90% times 90% times 90%. So you only use 72% of the electricity to run a motor at 90% of its speed. And so likewise, if you could slow it down to 80%, you're cutting the electricity in half. So if any type of process where you have a pump or a blower that you can slow down that motor, it's a huge energy savings. It's not a linear savings. We've switched some of our adhesives from a 350-degree set point down to 200 degrees, which cuts the consumption by about 70%. The energy savings by itself isn't a huge number because it's not that energy intensive, but there are a lot of advantages to switching to lower temperature adhesive, particularly on the safety front. If someone gets hit with a little bit of 200-degree glue, it's going to burn a little, but at 350, that's a pretty major injury. So a lot of the operators were happy to see this lower temperature glue. In the area of air conditioning, we put in a chilled water plant. It saved at least 30% over the older air conditioning units that we replaced. One thing I want to note, too, is all the initiatives that we implement were all cost justified. I don't have any kind of a special budget for sustainability where I get a blank check and do whatever I want. I have to compete with all the other projects to hit the hurdle rates. So any of these projects, they either had a good payback and outcompeted other projects, or in the case of the air conditioning system, those were at the end of their life and obsolete, and they needed to be replaced anyway. we didn't necessarily justify a brand new air conditioning unit with a 3-year payback. But they had to be replaced, and it was not hard to justify the incremental cost of getting a more efficient unit over a standard model. Some other air conditioning upgrades that weren't chilled water, you could still pick up 15 or 20%, getting like the higher SEER ratings if it was like a heat pump on a small office. So we do specify above and beyond the minimum standards for heat pumps. Air conditioning economizers. So the economizer is basically using free air. If the outside air is cool enough, you can use that as a source instead of having the compressor run. If in an office building, that may not be as much of an issue because if it's cold outside, you probably don't have the air conditioning on anyway. But for us in a manufacturing facility, our packaging floor with all the different glue units and shrink tunnels, we run the air conditioning 12 months a year. So when we put in the new chiller plant, we got economizers, and now for 3 months of the year, we have free cooling in that room that previously had been mechanically cooled. So that was a big savings in the wintertime. Still have to have the air handler powered, but the actual cooling process is free. Compressed air leak detection. Mentioned earlier about compressed air is notoriously inefficient. Only 15 to 20% of the electricity that goes into that compressor actually makes air, and then typically you have a leak rate anywhere 10 to 30%. So you're not very efficient to begin with, and then you end up wasting upwards of a third of your air. So if you can have a good leak detection program to keep that leak rate down, you'll save a lot of money. Apparently, the rule of thumb is even a well-maintained plant with a good leak detection program still has about a 10% leak rate. And then sleep modes for dust collectors, conveyors, and equipment. That kind of common sense. If you're not using it, have it shut off. In our case, we had a lot of things that ran automatically all the time. You had to manually go shut it down, so we've started to automate some of that. So if there's a conveyor that's running between two pieces of equipment, if those two pieces of equipment are off, the conveyor will automatically shut off. But for years, those conveyors would just run around the clock. People could be home on the night shift and still had conveyors running. And then Energy Star reflective roof and proper insulation. We replaced an old section of roof with a white roof that was reflective, and then we also added insulation at the same time, and it made a noticeable difference in our cooling. The air conditioning system was much less taxed after we put on that new roof. And again, that one wasn't justified, but we needed a new roof anyway, and it wasn't very expensive to justify adding the insulation and getting an Energy Star roof versus the cheapest roof that we could have purchased. So the third-party own and operate model, this is something it's an interesting way to get around some of the bigger projects if you want to save capital. You just saw an example of this with the CHP system that Chris can provide for you. So we've had a similar type of financing model. That chiller plant that I referenced on the previous slide, we don't own that chiller plant. We had a third party. They took out all the old air conditioning units. They provide the new chiller plant, all the piping loop. They own the system. They operate it. They maintain it. And all we do is we buy the cold air that's produced every month. So we avoided a big upfront investment. And then the energy savings and the maintenance savings we're achieving is paying for the monthly fee we have to pay for the cold air. So we actually have two of those projects. One's in Hunt Valley, Maryland, just north of Baltimore, a 750-ton chiller. And then down in the New Orleans area, suburbs of New Orleans, right across the Mississippi River, we have a 250-ton chiller. If we hadn't done these third-party agreements, we probably would have wound up just putting one-for-one replacements of a bunch of DX units, and we would have picked up a little bit of efficiency, but going with the chiller plant, we had a much better efficiency gain utilizing this third-party model and preserving our capital for other projects. So, as they say, the proof is in the pudding. A lot of people, I start talking about some of these lighting upgrades and fixing compressed air leaks, and again, the boring stuff works. People say to me, well, you got a lot of equipment in this plant. How much energy are you really saving? So this is our actual results of our largest facility. Again, it's just north of Baltimore. It makes all the spices that you see on the store shelves for the entire country. It puts about $1 billion of spices out a year. And you can see in 2006, this is right before we first got started with the first metal halide replacements. We used just under 26 million kilowatt hours to make 80 million units of product. And you can see by the time we got to 2015, we had just under a 20% absolute reduction. But at the same time, the plant has grown by 50%. So on a per unit basis, we are down about 40-some%. As you can see, the last 2 years, we have stalled somewhat in our progress, but we do have an air compressor project going in next year that should keep that downward trend, pick back up on that downward trend. That air compressor project alone is going to save us a couple percent. About 25% of our electric bill is the air compressor system. So getting a nice air compressor project is going to really get that number moving again downward. Moving on to renewable energy. Again, you know, my pet peeve is don't overlook energy efficiency. I've heard it said that you got to eat your energy efficiency vegetables before you get to renewable energy dessert. So on the plan in Hunt Valley, we do have a solar array. It's a 4-acre system. It's rated at 950 kilowatts, so that's how much it puts out when it's full sun. It's like at noon on a sunny day. It puts out the instantaneous rate of 950 kilowatts. It ends up generating about the same amount of power that 100 homes would use. And again, it's another third-party agreement. So we have a power purchase agreement with Constellation Energy. They upfronted the whole cost of the array. They own the array. They have to maintain it. If anything happens, they have to fix it. We just buy the solar power every month, but the solar power is cheaper than our price from the grid. So we're saving money on our electric bill while buying all of this solar energy. We put in a second system at distribution center in Belcamp. This is the same place where we're doing the LED lighting project here between here and Philly. It's about twice as big as the one in Hunt Valley. It's an 8-acre system. It's rated at 1,800 kilowatts. And again, it's a power purchase agreement set up. At the time we put this in, which has been a few years now, about 1 out of 5 panels in Maryland were on McCormick roofs. That number has since dropped quite a bit as solar's gotten more popular. So the facility, what's interesting about the facility in Belcamp is that it's a net electricity exporter. So you can see going back to 2006, we spent 4 or 5 years cutting our electricity consumption in half, mostly through lighting because that building does not have a lot of equipment. But we did a couple air conditioning upgrades, some sleep modes on some pallet conveyor. So we had a 5-year effort where we cut the electricity consumption in half. Then we put the solar array on, and that green bar you see there for 2011, that was only like an 11-month year. So we came up a little short in 2011, but since 2011, we make as much power on the roof as we consume inside the building. And this shows the importance, too, of leveraging that energy efficiency. If we hadn't have done the energy efficiency projects, the solar array would only be making half of our power because we maximize the roof space. That's as much solar as we can get is how much we're making. So moving on to some other initiatives, water reduction. We had some water-cooled equipment that we replaced with air-cooled equipment, and that has some pretty big reductions. That particular piece of equipment was a vacuum generator. It ran 24 hours a day, 7 days a week, so we had water running down a cooling process. It was single-pass cooling, so meaning that you used the water once. The water went past that motor and right down the drain, 24 hours a day, 7 days a week. To me, that should be illegal, but you know, I'm a little bit of a tree hugger, but I don't see why you should be allowed to do that. But we were allowed to do it. So that process of single-pass cooling, eliminating that, is about a 90% reduction. And for the whole facility, it cut the bill by about 40%. We have another area where we're doing single-pass cooling now at that facility in New Orleans, where we have an air compressor, and anytime the temperature gets over 80 degrees, we're doing single-pass cooling and dumping city water down the drain. But the chiller plant that we just installed, we're tying in that now to the cooling of the air compressor. So we're going to eliminate that single-pass cooling by using the chiller plant. So for waste reduction, we have an interesting program where they talk about reduce, reuse, recycle. So in that order. So we used to recycle all our corrugated boxes, the waste boxes. You bail them up and send them out to the recycling company. So we worked with a company now that buys our boxes for reuse. So instead of recycling them, they actually will get used again. The ideal scenario that we have set up is we'll actually send the boxes back to the vendor that we got them from in the first place, and they'll repack them. This is like for the caps and the bottles, empty caps and bottles that come into our plants. We'll send them back and get them reused. So for recycling is a commodity. They call it the OCC yellow sheet. There's a fixed price for recycling rates that the industry uses, and it does fluctuate up and down, but we're guaranteed by contract that we'll get a 15% premium over the OCC rates anytime a box is reused versus recycled. So the reuse program is more profitable for us and better for the environment. Likewise, our supplier, when he buys a used box from the third party who's handling the program for us, they're guaranteed to get a savings over the cost of a new box. So we're saving money, our supplier's saving money, and then the margin in between, the company used cardboard box, that's how they cover their costs. And we do track how many times we can reuse the same box, and we'll get as many as 4 or 5 uses out of a box before it starts to get too beat up, and then at that point we bail it up and recycle it.